Hello everyone, myself Soumya BG, Assistant Professor, Department of ECE SJBIT. The subject is Digital Communication. Subject code is 18EC61. I am discussing about the Module 1 topic, Band Pass Signal to Equivalent Low Pass. Let us discuss about basic digital communication transformations. In the basic digital communication block diagram, we have come across the formatting, or we can call it as source coding. This actually transforms source information into digital symbols, and it selects compatible waveforms. It introduces redundancy, which facilitates accurate decoding despite errors. It is very much needed for reliable communication. Then we have come across the modulation and demodulation. The modulation is the process of modifying the information signal to facilitate the transmission, and demodulation reverses the process of modulation. It involves the detection and retrieval of the information signal. We have got two types in this: coherent modulation, demodulation, non-coherent modulation, demodulation. The coherent type requires a reference info for the detection, whereas the non-coherent type does not require the reference phase information. I repeat, in basic digital communication block diagram, we have come across some of the transformations. Let us discuss those transformations here. Starting with the formatting or source coding. This transforms source info into digital symbols. It selects the compatible waveforms. It introduces redundancy, which facilitates accurate decoding despite errors, and it is essential for reliable communication. Coming to the next one, that is modulation, demodulation. The modulation is the process of modifying the information signal to facilitate the transmission, and demodulation reverses the process of modulation. It involves the detection and retrieval of the information signal. There are two types in this modulation, demodulation: coherent and non-coherent. Coherent requires a reference info for the detection, whereas non-coherent does not require a reference phase information. Now, coming to the third transformation block, which we call it as coding, decoding. This translates information bits to transmitter data symbols. The techniques these are being used to enhance information signals so that they are less vulnerable to channel impairment. Channel impairment in the sense noise, fading, jamming, interference. Like this, these are some of the channel impairments that can degrade the signal. And there are two categories in this coding and decoding. First one is waveform coding and structured waveform coding, structured sequences. It produces new waveforms with better performance. Structured sequences, they involve the use of redundant bits to determine the occurrence of error, and sometimes they will correct it. Now, coming to the next section, multiplexing or multiple access is synonymous with the resource sharing with other users. It is basically used for resource sharing with the other users, multiplexing as well as multiple access. This already we have discussed in the while discussing about typical digital communication system block diagram. We have types like frequency division multiplexing or multiple access. Frequency division, multiple access. I repeat, coding, decoding is used for translating information bits to transmitter data symbols. These are the techniques used to enhance the information signal so that they are less vulnerable to channel impairment like noise, fading, jamming, interference. There are two categories: waveform coding and structured sequences. The waveform coding produces new waveforms with better performance. Structured sequences, they involve the use of redundant bits to determine the occurrence of the error, and sometimes they even correct the error. Next, we have multiplexing and multiple access techniques. They are actually the one which allows for sharing with other users, sharing of the channel with the other users. There are many types, like one of the type is frequency division multiplexing, as well frequency division multiple access, similarly code division multiplexing or code division multiple access. time division multiplexing or time division multiple access. This slide basically highlights the basic digital communication transformations, yeah, and the types that are involved in each transformation. Coming to the formatting, in formatting we have character coding, sampling, quantization, pulse code modulation. In the formatting, what are the processes that are involved is character coding will be involved, sampling, quantizing and pulse code modulation. Next, coming to the source coding, the next block. In the source coding, the tasks that are involved will be predictive coding, block coding, variable length coding, synthesis or analysis coding, lossless compression, lossy compression. Next, we have baseband signaling. In baseband signaling, we have PCM waveforms or line codes. In this non-return to zero code, return to zero code, phase encoded multi-level binary, M-array pulse modulation, PAM, PPM and PDM. Next, we have equalization. In equalization, we have maximum likelihood sequence estimation, MLSE, equalization with filters, transversal or decision feedback, preset or adaptive, symbol spaced or fractionally spaced. Next, coming to the bandpass signaling, we have either coherent or non-coherent. In coherent, we will be having phase shift keying, frequency shift keying, amplitude shift keying, continuous phase modulation, CPM and their hybrids. Next, in non-coherent, we have differential phase shift keying, frequency shift keying, amplitude shift keying, continuous phase modulation, hybrids. Next, coming to the channel coding part. In channel coding, as I mentioned, there will be two types. One is waveform coding, another one is structured sequences. In waveform coding, we have M-array signaling, antipodal, orthogonal, trellis coded modulation. In structured sequences, we have block, convolutional and turbo. Now coming to the next synchronization block, block, that is synchronization. In synchronization, we have frequency synchronization, phase synchronization, symbol synchronization, frame synchronization and network synchronization. Next, we have multiplexing or multiple access block. In this, we have frequency division multiplexing or frequency division multiple access, time division multiplexing or time division multiple access, code division multiplexing or code division multiple access, space division multiple access, polarization division. Next, coming to the spreading part. In spreading, we have direct sequencing, direct sequence spread spectrum, frequency hopping, time hopping and hybrids. Coming to the encryption block. In encryption block, we have block and data string. This slide actually gives an insight of the different tasks that are involved in the digital communication transformations. Now let us just briefly highlight the main points that are involved in the transmission. The transmitters modulate the analog messages or the bits in case of a digital communication system for transmission over the channel. The receivers, they recreate the signals or the bits from the received signal by mitigating the channel effects also. And the performance metric for analog systems is fidelity, whereas for digital it is the bit rate and error probability. I repeat, the transmitters modulate the analog messages or bits in case of a digital communication system for transmission over the channel. The receivers recreate the signals or the bits from the received signal by mitigating the channel effects. The performance metric for analog systems is fidelity, whereas for digital it is the bit rate and error probability. Now let us have an answer to the most important question: why digital communications? The answer to the most important question: why digital communication? In digital communication, we can easily regenerate the distorted signal because the regenerative repeaters along the transmission path can detect a digital signal and retransmit a new, clean, noise-free signal. These repeaters prevent accumulation of noise along the path, whereas this is not possible with analog communication systems. The first advantage is we can easily regenerate the distorted signal because regenerative repeaters along the transmission path can detect the digital signal and retransmit a new, clean, noise-free signal. These repeaters prevent accumulation of noise along the path, whereas in analog communication system this is not possible. Now coming to the next advantage, there is a two-state signal representation in digital communication. Two-state signal representation. The input to the digital system is in the form of a sequence of bits. Either it will be binary or M-array form. And due to this, there is immunity to distortion and interference. Digital communication is rugged in the sense that it is more immune to channel noise and distortion. This is very important advantage of digital communication. There is immunity to distortion and interference. So we can tell that it is rugged in the sense that it is more immune to channel noise and distortion. In digital communication, the hardware is more flexible. Digital hardware implementation is flexible and permits the use of microprocessors, mini processors, digital switching and VLSI. The hardware is more flexible in digital. The digital hardware implementation is flexible and permits the use of microprocessors, mini processors, digital switching and VLSI. Next advantage it has is shorter design and production cycle. The design and production time that is needed in the digital communication is very much shorter. The time needed will be shorter, and the cost that is incurred in order to design this digital system is low. The use of LSI and VLSI, large scale integration and very large scale integration in the design of components and systems have resulted in lower cost, and it is very much easier and more efficient to multiplex several digital signals. Many signals can be transmitted together on the same channel by means of multiplexing in digital communication. There are digital multiplexing techniques like time and code division multiple access. They are very much easier to implement than analog techniques like frequency division multiple access. In digital communication, the hardware is more flexible. Digital hardware implementation is flexible and permits the use of microprocessors, mini processors, digital switching and VLSI. It is having a shorter design and production cycle. It is low cost. The use of LSI and VLSI in the design of components and systems have resulted in lower cost. They are easier and more efficient to multiplex several digital signals. Digital multiplexing techniques like time and code division multiple access are easier to implement than analog techniques like frequency division multiple access. In digital communication, we can combine different signal types like data, voice, text, etc. The most important advantage in digital communication is many different types of signals can be combined, like data can be combined with voice, it can be combined with text. Data communication in computers is digital in nature, whereas voice communication between people will be analog in nature. The two types of communication are difficult to combine over the same medium in the analog domain. Using digital techniques, it is possible to combine both the format for transmission through the common medium. This digital communication can be used to combine many different types of data. For example, in data communication, which we use in computers, is digital in nature. Whereas when I go for voice communication, it happens between the people and it is in analog in nature. These two communications are totally different, or they are difficult to combine over the same medium when we go for analog communication. Whereas when we go for digital communication, it is possible to combine both the format for transmission through the common medium. So this digital communication is very much easier when we use different types of data. Now, encryption and privacy techniques are very much easier to implement in digital communication, whereas in analog communication we cannot do encryption. Technologies cannot be involved in analog communication. So better overall performance will be there, and digital communication will be inherently more efficient than analog, since we can use encryption as well as privacy techniques, and this is more efficient in the sense that it can be used to realize the exchange of signal to noise ratio for the bandwidth, and digital signals can be coded to yield extremely low rates and high fidelity as well as privacy. The digital signals can be coded to yield extremely low rates and high fidelity as well as privacy. So these are some more advantages of digital communication. Now coming to the disadvantage of this digital communication, it requires a reliable synchronization. Whenever we use digital communication, the synchronization between the receiver and the transmitter should be very much reliable, and it requires A to D conversions at high rate. Since we are doing digital data transmission, at the transmitter part we need a to D conversion, and that A to D conversions are to be done at high rate, and it requires very much larger bandwidth compared to the analog communication, and there is a non-graceful degradation here. And coming to the performance criteria, it is very much like in the sense we can tell that it is having less performance compared to the analog, and here probability of error and bit error rate will be considered, which is very much cumbersome to do calculate and redefine. After knowing the advantage of digital communication and its disadvantage, now we need to know what are the goals that we come across in communication system design. The first important goal is we need to transmit the data at a higher rate. The rate of transmission should be higher. So the first goal is we need to maximize the transmission rate. The transmission rate has to be maximized. Similarly, whenever we are transmitting the data, we need to make the system utilization properly. So we need to maximize our system utilization. U has to be increased, and our goal of communication system will always be to reduce the error. So the third goal here in the communication system design will be to minimize the bit error rate, to minimize the PE value. And in the digital communication, in the disadvantage, I told that it requires more bandwidth. So one more goal in the communication system design will be to have a minimized required system bandwidth. We need to minimize the required system bandwidth, that is W. W has to be reduced. Similarly, whenever we when we go for digital communication, many blocks are being involved that we understood in typical digital communication system block diagram. There are many huge number of blocks that are involved, and the system complexity is little bit more. So our next goal will be to minimize the system complexity. Next is power. The power ratio can be written in the form of energy and noise as EB by N0. Our next goal will be to reduce this required power, that is EB by N0. These are the important goals in the communication system design. The first is maximize transmission rate, maximize system utilization, minimize bit error rate, minimize required system bandwidth, minimize system complexity, minimize required power. This is about the discussion regarding the basic digital communication transformations, advantages and disadvantages of the digital communication, and finally the goals of the digital communication design. Thank you.